Hello, everyone. Good evening. To authors and invited guests, welcome to Technical Session 12E. Myself, Ishita Soryan, and this session will be moderated by me. On behalf of Global Knowledge Research Foundation and GR Scholastic LLP, it is my great pleasure to welcome you to the 10th International Conference on ICT for Sustainable Development, ICT4SD 2025, Goa, India. The 10th edition of the conference is being organized in a hybrid mode. The physical event was held on 17th of July in Goa, and the virtual event is being held through Zoom from 17th to 19th of July 2025. I hope you will all enjoy the knowledgeable interactive sessions through the day. In this session, we have 10 presentations. Each presenter will be given 10 minutes for the presentation and 2 minutes for question and answer. On 9 minutes, I will raise a gentle reminder. There's another request to all the participants that you all stay connected with us till the closing remarks. If you have any query or update, then you can write it to me in the chat box. Just before we get started, I'd like to introduce you all to our session chair. We have with us Professor Vinod Thumar, who is working as an assistant professor in Vishwakarma Government Engineering College at Ahmedabad, Gujarat. He has more than 14 years of experience in industry as well as academics. His research areas are data security, blockchain technology, and AI. He's also involved with an expert of team of professionals working in RPA, ML, and AI. We welcome you, sir. We'll be proceeding with our paper presentations. I'd like to first call our first presenter, Vedant Chandor, with the paper titled Advanced Road Condition Monitoring Using Machine Learning and Computer Vision. Vedant, if you're ready with the presentation, then please go ahead. It seems we do not have him in the meeting yet. We'll be proceeding with the next presenter, Sai Hemangnya, with the paper titled An Enhanced SVM Model Optimized with Minimum Base Error Rate for Mental Disorder Detection. Ma'am, if you're ready, then you may start with the presentation.
Uh, am I audible?
Yes, ma'am, you're audible.
Good evening, everyone. Today, I'll be presenting a research project titled An Enhanced SVM Model Optimized with Minimum Base Error Rate for Mental Disorder Detection. So, the core idea behind this work is to explore how machine learning can improve the early detection of mental health conditions using eye tracking data. Mental health is a critical concern, especially among young individuals today. The challenge lies in the fact that diagnosis often happens too late, and traditional methods rely heavily on self reporting and clinical judgment, both of which can be subjective. Early and accurate detection is essential to ensure timely support and care. So, eye tracking data captures subtle behavior patterns that reflect a person's cognitive and emotional state. By training a model on these patterns, we aim to identify signs of mental distress. We used a dataset consisting of eye tracking data from 139 students aged between 15 to 21 years. This was an open source dataset available on GitHub. The participants were labeled using the DAS 21 depression scale. DAS stands for Depression Anxiety Stress Scales. After applying data augmentation for class balance, we had a total of 228 samples. Each sample contains 21 features related to pupil size, blink rate, fixations, and saccadic movements. While 228 samples may seem limited, this is common in clinical research where access to high quality label data is constrained. So the goal was to build a model that performs well even when the data is small. And the idea was to reduce misclassifications even when the data is limited. Moving on to the methodology. We began by encoding the class labels numerically and applied feature normalization using standard scalar to ensure uniform contribution. The dataset was then divided into training and testing sets to evaluate generalizability and avoid overfitting. Deep learning models like CNNs and RNNs typically require large datasets to perform well. With smaller datasets, they are prone to overfitting and instability. So we used SVMs. SVMs are more suitable for structured, lower volume data and provide more robust decision boundaries under these conditions. And for optimization, we used MBER. MBR stands for minimum base error rate. It is a decision optimization technique that reduces classification errors by adjusting the boundary based on prediction confidence. Instead of relying solely on the most likely class, it minimizes the risk of misclassification, making the model more reliable for sensitive use cases like mental health screening. So this is a visual overview of our model pipeline. We start with the raw data set, which is the eye tracking data. First, we detect the label column. That's what separates the inputs from the target class. Then we apply feature scaling using standard normalization techniques so that all the features are in the same range. Otherwise, some features might dominate the learning process. Then we apply feature scaling. After that, the data goes into SVM classifier, which learns how to separate the depressed and healthy participants based on the input patterns. Once the SVM gets its decision boundary, we pass it through MBR optimization. This step adjusts the boundary to minimize the wrong chances of predictions. It fine tunes how confident the model is before it makes a decision. Finally, the optimized result is passed into the prediction phase, where the model tells us whether the input data most likely belongs to a healthy individual or someone dealing with depression. So these were the results. This table compares the performance of different machine learning models on our dataset. We evaluated them using 4 key metrics: accuracy, precision, recall, and F1 score. As you can see, the SVM model by itself already performs quite well, but once we applied MBR optimization, it gave us the best results across all 4 metrics. Even though our model performed well, there are a few limitations. First, the model is sensitive to hyperparameters, so fine-tuning values like C and gamma in SVM makes a noticeable difference in performance. Second, while the data was clean and balanced through augmentation, it's still relatively small in size. Lastly, the model was tested only on eye tracking data, so we haven't yet validated how it would perform on other physiological inputs like EEG, HRV, or GSR. So moving forward, we plan to improve the model's generalization by incorporating multi-model inputs such as EEG or heart rate data alongside eye tracking. I've already started exploring EEG datasets in raw ADF format, converted them to text, and the next step is structuring the data into CSV for feature extraction. We're also looking into automating hyperparameter tuning using methods like Bayesian optimization or genetic algorithms. So in conclusion, to sum it up, this project shows that a lightweight SVM-based model optimized using MBER can offer strong performance for mental health detection using eye tracking data. It's fast, accurate, and works well even in low data settings, which makes it practical for real-world clinical use. And with future integration of more physiological signals, this approach has strong potential to support early objective mental health diagnostics. Thank you. Any questions?
So, would you like to ask any questions?
No questions. Next presentation, please.
Sure, sir. We'll be proceeding ahead with our next presentation. I'd like to call upon Shreya with the paper titled Emoji Prediction for Sentiment Analysis, a comparative study of LSTM and BERT models. Ma'am, if you're ready, then you may start with the presentation. Shreya.
Yes, good afternoon, ma'am. I'm sharing the screen also. Well, ma'am, is my screen visible?
Yes, ma'am, it is visible.
Yeah. Good afternoon, everyone. I am Shreya Patan Shetty from KL Technological University. Our project is emoji prediction for text sentiments. We all are familiar with emojis and know what they are. They
Excuse me, ma'am.
constitute.
Could you please put your presentation in slideshow mode?
Uh,
Hello. In the header, you will see slideshow. Click on that.
Ma'am, now is that okay, ma'am?
Ma'am, there is a slideshow option in the toolbar up ahead. Please click on that.
Bit left. Slideshow button. Just next to that. Next to that. Yes. From the beginning.
Okay. Yeah. Is that okay, sir?
Yes, ma'am. It's perfect. Please go ahead.
Yeah, we all are familiar with the emojis and know what they are. They constitute a language without a text. They make conversation easier. That's why we acknowledge this. We also celebrated World Emoji Day just the day before yesterday. Uh, Emojis add a tone and clarity of thought, which is not possible with just words, making conversation entertaining and engaging for both the parties. As we know, currently keyboards in our smartphones can predict emojis, but only based on some hard coded logic and certain keywords and tags mapped to respective emojis, but not on the context of the sentence that the user types. Therefore, this presents a problem statement of evoking an emoji based on the meaning of the text data the user has typed. So these are our motivation to enhance the communication and reduce the time of communication and growing the popularity of emojis in social media and other platforms. The objectives are as follows: accurate prediction of emoji for given text input, and it should be user centric model, and there should be a real world application of this. So this is the rough sketch of what framework we have used. We have given the text input, then pre-processed it, and then we have compared the BERT model as well as LSTM for the emoji prediction function. Then talking about dataset, our team itself we have prepared the dataset which contains 70,000 samples for training and 25,958 samples for testing. Here we have given labels for each of the emoji as shown here. We have taken emojis like happy, sad, anger, cry, or celebration like that. Up till 20 emojis we have taken, and each emoji has the 3,500 sentences. Data is balanced across sentiment categories. Then coming to data pre-processing, we have cleaned the text. The raw input text will be having some exclamation marks or something which will not contribute to emoji prediction. So we have cleaned the text so that only the clear helpful text will be taken for emoji prediction process. Then we have tokenized using BERT tokenizer, where the sentence will be broken into tokens. These are CLS and ACP are the special tokens used by the BERT model, where CLS token is for classification process and ACP token is for separating the sentences. Then conversion to token ID. The tokens, the model will not understand the words, so it should be coded like numbers form. So we will be converting the tokens to token IDs. Then we will be then the padding and truncation we have performed, if we fix the length of a sentence to 64 tokens. If the sentence is shorter than the 64 tokens, then we will pad the sentence by filling up the zeros, or else if the sentence is longer, we will cut down it to 64 tokens, that is truncation. Then this is the BERT model architecture that I will be explaining. Uh, Talking about BERT, it stands for bidirectional encoder representation for transformers. We used BERT based model, which has total of 12 layers. It was developed by Google in 2018 and completely changed how we process text using AI. BERT works by reading the entire sentence in both directions, that is from left to right and right to left at the same time. This is unlike other models like LSTM or GRU, which read only from one side at a time. Because of this, BERT understands the complete context of each word in a sentence. BERT was pre-trained on a massive data set called Books Corpus and Wikipedia, and is trained on a masked language modeling and a next sentence prediction. In our project, on the top of BERT, we have added a few layers. Like we fine-tuned our model by adding the dense layer of 256 neurons with a ReLU activation and a dropout layer to avoid overfitting of 8.2. Then final output dense layer of constituting of 11 neurons for every emoji. Then we have used categorical cross entropy as the loss function and Adam as optimizer. And also during training, we monitored model accuracy. And coming to the other model we have studied, that is LSTM, long short term memory. Here also the same procedure is followed, like we pre-process the text and converted the word indices to dense vectors, like to capture the semantic meaning, and then stacked two LSTM layers of each of 64 and 32 minutes for capturing sequential patterns, and applied dropout layers to reduce model overfitting and improve the generalization. Then dense output layer uses softmax activation to predict emoji class probabilities, and the loss function to know how well the model is performing. Then here in LSTM also we have used the Adam optimizer, and we trained the LSTM model for 20 epochs with a batch size of 32, and we have evaluated the model. These are the results we have come across, that is the model BERT model has achieved about 95% of accuracy. As we can see, as the number of epochs has increased, the accuracy is also increased, and the model loss is decreased. So this proves that the model not only predicts the emoji, but it does it consistently. And we confirm that BERT performed well than LSTM. This is the confusion matrix. So we can see all the values that predicted labels are of a high accuracy. Then our contribution are like we created our own emoji data set by cleaning and balancing the overall data set, and fine-tuned the BERT model specifically for emoji classification, which has performed very well. So our project not only predicts emoji, but it also understands the emotion, and this can be used in messaging apps, social media, and at any place where emotion detection is crucial and important, like where the person will be unable to express the things in the text format, or the people with the busy schedules can also communicate effectively through emojis. And these are our team member contributions and references we have studied. So thank you.
My question is that initially you have mentioned that you have achieved accuracy over 90%, and in your contribution slide, you have mentioned that you have achieved accuracy over 95%. So what is the difference between these two words?
So let me go through the slides.
Yes.
Yes, I mentioned like we have achieved about 95% via training accuracy, and like
Yes.
about
Here you have
yeah.
mentioned over 95, but initial slides you have mentioned that you will achieve accuracy over 90%.
Sorry, sir. Like we have achieved about 95% actually. Yeah.
Okay. Okay. It's fine.
Uh-huh.
Good.
Yes.
Next one,
Thank,
please.
thank you, sir.
Thank you, ma'am. Thank you, sir. We'll be proceeding with the next paper presentation. I'd like to call upon Krish Deshpande with the paper titled Entity Recognition for Defense Intelligence. So if you're ready, then you may start with the presentation.
Yeah, I'll just share my screen.
Yeah.
Right. So, and I was so entity recognition for defense intelligence. Hi, my name is Krish Deshpande, and I'm here to present my research project, Entity Recognition for Defense Intelligence. This is a domain-specific system that identifies and maps key entities, the relationships between them, and a code word, uh, if available, in the defense-related text data using NLP and graph-based visualization. The problem statement we found was quite timely and urgent. Defense and intelligence agencies today process massive volumes of raw, unstructured information from phone calls, transcripts, WhatsApp chats, intercepted communications, etc. So, manually analyzing this data is not only slow but also error prone and unsustainable at a large scale. More importantly, traditional NLP models like Spacey or BERT, they are powerful, but they are not trained to understand domain specific contexts like mission code names or strategic locations, etc. So they often misclassify or entirely miss these critical pieces of information. Uh, and these standard models also often struggle with informal or conversational data, typically found in the real world intelligence sector. Importantly, entities and relationships may go undetected or even be misinterpreted, resulting in fragmented or misleading intelligence. So, what we found during the literature review that we did was one paper said the prior research in NER for informal or noisy text highlights poor accuracy on non standard formats. Then there was also a need for entity relationship mapping, which we fixed, and the cybersecurity model limitations. So existing NER models suffer from false positives, missed mission terms, and also mainly they are not locally based and may suffer from infiltrations. So the project objectives that we had were a defense-focused NER system. We created a defense-focused NER system to extract names, places, geopolitical locations, organizations, and operations. Then hidden codework detection using POS and PyText rank. Then entity connection establishment. We used Network X to map these entities visually and then visualizing this data to get these nodes connected and display the data visually for faster and more intuitive interpretation. So, firstly, we use Spacey as the base model for named entity recognition. But this performs the primary entity recognition, identifying names, places, organizations. But we can't solely rely on this. So we added another layer of PyText rank. This is for the key phrase and code word detection using POS, as I said. Then Network X and GraphViz. So this is for the relationship mapping, Network X, and GraphViz is for the visualization in terms of nodes and the relationship between them, and POS filtering and dependency processing. So how the system works is, firstly, we ingest data. Uh, so firstly, the unstructured conversational data is inputted into the system, which is further cleaned and filtered to remove irrelevant tokens from the context. Then we apply the base NER and key phrase detection. Then we filter out entities which are noisy generic entities and add no value to the output. Then we map relationships using the co-occurrence and dependencies, and then we generate a visual like a mind map or relationship graph to get the data. And yeah, our innovative features are firstly the informal text focus. We focused on informal and conversational intelligence text. And so this isn't just about extraction. One of the key contributions is filtering out irrelevant terms that are this, that, or something that are nouns that just get identified by the spacey but don't actually add relevance to it. So that we did using the POS tagging and entity type filtering. Then the hidden term detection. This was using PyText rank. So detects hidden mission terms that uh, they can use to uh, uh, that might be missed by generic NER models. Then false filtering that and visual data conversion. So a sample output can be this. You can find one cluster to be a whole conversation. Then the nodes present the actual entities that are present in the conversation, which, for example, here can be Rafael India, Aviation Ghaziabad, and defense advancements. So custom models yield significantly higher precision than the base spacey and BERT models. So spacey gave an F1 score of 74%. BERT reached around 80%, but our tune system achieved close to 89% of accuracy. And false positives reduced through this entity type and POS filtering. The accurate clusters of related intelligence elements also uh, play a huge role in getting actionable information from a large amount of text, which saves a lot of time and which is really critical in actual mission conditions and environments. So the relationship mapping, what it indicates is how places, operation, and the organizations are linked. The nodes are entities and the edges show connection. The analysts can gain structured and real-time views of intelligence chatter, and this leads to a very reduced cognitive load. The practical relevance of this is firstly enhanced accuracy to process text data with higher accuracy and clarity. Real-time decision making is supported through visual intelligence graphs, and it is adaptable to data streams and can be easily adapted to ongoing surveillance and data streams, as the application can be remotely run without accessing the internet, ensuring no data breaches. And it's a modular design to allow expansion to more complex forms of data and data types. So, yeah, to conclude, the system improves over standard NER by customizing for defense-specific vocabulary and informal formats. It extracts relevant intelligence while minimizing noise, presents it in actionable visual form, and supports analytical workflow. The output is cleaner, faster, and more effective for modern defense operations. Thank you.
No questions. Next presentation, please.
Thank you, sir. We'll be proceeding ahead with our next paper presenter. I'd like to call upon paper presenter Dhanalakshmi with the paper titled IoT-based agribot for sustainable and smart pest control using CNN and ResNet. Ma'am, if you're ready, then you may start with the presentation.
Am I audible, ma'am?
Yes, ma'am, you're audible.
Yeah, good afternoon all. I'm Dhanalakshmi, a UG student from Sri Krishna College of Technology, Coimbatore, and it's my honor to present our research title IoT-based agribot for sustainable and smart pest control using CNN and ResNet at the 10th International Conference on ICT for Sustainable Development. And this work was guided by Dr. J. Dhanaselvam and Mr. R. Raj as assistant professors and co-authored with peers Prashant and Hari Prasad. Coming on to abstract, India is an agriculture-driven economy, but pest infestations and crop diseases remain major challenges affecting yield in crop like rice, wheat, and maize. Our research proposes a cost-effective, eco-friendly, smart agriculture solution by integrating deep learning and image processing and IoT enable automated pest classification and precise pesticide spraying. With a validation accuracy of 99.80%, our model reduces the number of cameras needed in IoT monitoring systems, and it lowers the usage of chemicals and minimizes environmental damages. And coming on to introduction part, pesticides are vital in modern farming, helping avoid 30 to 35% of crop losses. However, their excessive use of chemicals harms both human health and the environment. So, current application techniques either rely on manual spraying or mechanized spraying. In manual spraying, which is labor extensive or non-selective mechanized spraying, which results in unnecessary chemical exposure across the entire field, even where pests are absent. These outdated methods demand on intelligent alternative, and that's what we aim to provide. And justification. Agriculture system struggles with consistent pesticide application due to varying plant shapes, size, and field conditions. Over spraying damages crops and ecosystem, while underspraying leaves infestations untreated. Moreover, real-time environmental data such as temperature, humidity, soil moisture, light is often missed in traditional methods. Hence, we need a real-time, precise, and sustainable pest control system with low operational cost and maximum coverage accuracy. So we developed a solution using autonomous agribot powered by deep learning algorithm, image processing, and IoT. The robot navigates through crop fields, captures images of the leaves, classifies pest infection, and triggers an automatic sprayer with precision. Our system uses CNN-based pest recognition models combined with ResNet architecture and to handle low resolution images and identify the right pesticide treatment. This is not only reduces infrastructure cost, but also it's a less expensive widespread cameras network, but also makes the solution affordable for small and medium scale farmers. So our proposed system, here is how it works in detail. The AgriBot captures leaf images and processes them for signs of disease. If contamination is detected, the robot initiates targeted spraying. We use residual neural network RNN with the quadra attention, residual, and dense fusion technique to upscale image resolution and detects pests efficiently. The motor control is handled by L293D driver, while Arduino Nano operates the embedded system controlling the robotic movement and sprayer. The output includes pest classification, remedy prediction, and automated pesticide application. The block diagram outlines the interaction between various methods like image acquisition, pest detection, robotic navigation, and automated pesticide spraying, making the system modular and easy to troubleshoot or upgrade. Coming on to working flow chart, this flow chart shows the step-by-step process starting from the field scanning, image pre-processing, pest classification, and ending up in precision spraying. The robot automatically repeats the system across the field, ensuring continuous monitoring and pest management. So this is our proposed methodology, and it includes input acquisition via onboard cameras, filtering and segmentation of images, clustering and grayscale transformation, color space analysis followed by CNN-based classification. Each stage ensures accurate detection while keeping pre-processing time low. This design ensures real-time operation and practical field implementation. And this is a hardware setup. The AgriBot uses chases with the DC motors for navigation, motor drivers, and relay modules, and Arduino Nano as the control unit, and it consists of a spray module, Wi-Fi or Bluetooth modules for remote access, and high resolution cameras for pest detection. The system is cost effective and suitable for farms with limited access to advanced tools. Coming on to conclusion, our AgriBot ensures selective and smart pesticide application, reducing chemical overuse. The robot targets only infected plants, improving efficiency and safety, and it reduces human exposure to harmful pesticides. Our AI-based model helps make agriculture smarter, more precise, and sustainable. And sustainable development goals 7, 13, and 15. And, thank you.
You have shown a hardware setup in your presentation, right? So is there any specific requirement of hardware specification for implementing this model?
Hello, sir. I am Prashant Shivkumar from teammate
Yes.
of the Dhanlakshmi. Shall I answer the question?
Yes.
Yes, sir. There
Okay.
is no specific requirements for that bot, sir. It can work on any terrain. It's just a
Okay.
prototype, sir. We can
Okay.
remodel the project at any specifications.
Okay, good. Nice work. Very good presentation and good work. All the best.
Thank you, sir.
Thank you, sir.
Next presentation, please.
Thank you, sir. We'll be proceeding with the next paper presenter. I'd like to call upon paper presenter Nikita Bhatt with the paper title Joint Feature Learning and Hashing for Multi-Model Data while Cosine Normalization. Ma'am, if you're ready, then you may start with the presentation.
Yes.
Yeah.
Can you see my screen?
Yes, ma'am, it is visible.
Okay, so good afternoon, everyone. I will present my work on joint feature learning and hashing for multimodal data via cosine similarity. So this is what the outline of my today's presentation, where I will focus on multimodal data, its challenges, the standard algorithm to solve the problem called nearest neighbor search and approximate nearest neighbor search, indexing schemes available for approximate nearest neighbor search, followed by the important domain called cross-model retrieval, its challenges, and the proposed model, followed by experimental result and the conclusion. So before we go further, due to growing popularity of social media, a huge amount of data having different modalities are generated, like text, image, video, audio, etc. So these different modalities of data are called the multimodal data, which is having different sources like Facebook, Twitter, Flickr, YouTube, etc. And this multimodal data is having huge applications in various domains like hot topic detection, personalized recommendation, and multimodal data. Out of this, my focus is on the multimodal retrieval. So basically, this is what the motivation of my work, to have an effective feature representation of multimodal data, because different amount or different types of modalities are present, to learn a good association between the multimodal data in order to have the effective retrieval. And whenever we retrieve the information of interest, then it should be in the form of cross-model retrieval. So it says that whenever we try to retrieve something, then query and retrieval is having the different modalities of the data. So till date, the standard search algorithm is called nearest neighbor search. So if we give any query, that algorithm tries to find the most similar data points available in our database, and based on that, the information is retrieved. But this algorithm is having many challenges, like it is very expensive in multimodal data, and for performing the retrieval operation, we need to load the entire data set inside the memory, and due to the growing popularity, we have a huge amount of data. So this nearest neighbor search won't be preferable when we have huge amount of data. To avoid this problem, we have another variation of the searching that we call approximate nearest neighbor search, where the goal is not to find the exact retrieval, but our goal is to find the approximate retrieval, which is comparatively efficient compared to nearest neighbor search. And there are two indexing schemes available for approximate nearest neighbor search. One is tree based, which follows the divide and conquer strategy. But as we know that the worst case complexity for the tree based approach would be big O of n, where our algorithm has to work proportional to the height of the tree. So if we have high dimensional data, then tree based scheme won't work. So for that, we have to think about another indexing scheme called the hashing base, where each item in the database is represented in form of a hash code. And such complexity would be efficient here, either linear if collision is generated, or the constant if there is no collision, which is better than the tree based approach. And again, due to this representation, the hashing based approximate nearest neighbor search is taking less space compared to tree based. So in terms of time and space, both hashing based approximate nearest neighbor search will work, and that is what the direction in which I am working. So again, if we go into detail of the hashing, then we have two-way single view hashing, where it focuses on the single modality of the data. And in contrast to it, we have multi-view hashing, where it is based on the multimodal data. So again, our focus is to go with the multi-view hashing. Now, again, if we go into detail of the hashing techniques, we have data independent technique, where the hash function which is generated in order to perform the hashing is independent of the training data. And second is data dependent method, where my hash function is dependent on the training data. So our focus is on the data dependent method. Again, we have two methods: unsupervised learning, which use only the unlabeled training data to learn the hash function, and in contrast to it, we have supervised hashing method, which uses label information to learn the hash code. So here from this slide, our focus is on the multi-view hashing and data dependent supervised hashing method. So again, for the cross-model retrieval, the biggest challenge is to find or to preserve the modality gap, because each modality is having its own representation. So if we focus on image, its representation is different, text different, video different. So each modality is having different representation. So the biggest challenge is to generate the common subspace where the semantic similarity across the modality is preserved. And once the common subspace is generated at the end of the training, for any testing purpose, if we give any query as the input, then output can be some other modality. That is what the work in which we are interested. But the type of common subspace which is generated is fall inside two categories. One is real valued representation, where real representation of the different modalities can be preserved in form of a common subspace, and second would be the binary value representation, where the compact form of the semantic similarity across different modality is preserved. And if we go into the literature survey, this is what the work which is already done. So here we can observe that the modality which is used is image and text. For image and text, a separate network is being used, and a common subspace is generated by considering the supervised information, because our focus is on the supervised learning environment. and the common subspace which is generated, which contains the compact representation which preserves the similarity with our information called S. Now, again, if we go into detail of this, then the first phase focuses on the training phase, which uses image, test set, and the similarity matrix as the input. During the training, we have used a convolutional neural network for image, and deep network we have used for the text modality, and the output would be the binary code that we call the binary value representation in form of a common subspace. Once the training gets over, during testing phase, if we give any image modality, it generates a hash code for it and it tries to find the Hamming distance. Now, during training phase, when the feature is learned, we have image and text modality, and both network follow some strategy, and based on that F and G networks are generated, which represents the image and text features. Similarly, for image representation and text representation, we find the cost function which tries to find what is the difference between the actual and the predicted one. During the binary code generation, whatever features are generated for image and text, based on that, we try to generate the binary representation, and we try to preserve the similarity between the binary code and cross-model similarity with F and G. So once the representation is generated, we get this output, and this is what the cost function that we have designed. Now, during testing phase, if we give any image as the input, the feature learning can be carried out, and from that a binary code is generated. Once the binary code is generated, we need to identify the distance between the generated binary code with the code which is generated as the output. So for that, we are having two Hamming distances. One is called the Euclidean distance, and second one is called the cosine similarity. Up till now, whatever research papers we have referred, they have used the Euclidean distance, and from that a pairwise inner product loss is being calculated. But this method works well when the vector length of generated binary code is the same. The problem arises when the vector length would be the different. So for that, we have replaced the Euclidean distance in form of a Hamming distance to something called the cosine similarity. So my problem statement would be to have the existing deep based cross model retrieval system which follows the concept of inner product based learning, which is not good surrogate of Hamming distance when the vector lengths are very different. So if we need to improve the cross model retrieval system, then we need to find the Hamming distance between similar points, and it must be as small as possible. The loss must be minimized, and the retrieval information is improved in comparison with inner product. So my first proposed work focuses on the replacement of the Euclidean distance with the cosine similarity due to the characteristic of cosine
Excuse me,
similarity.
ma'am. I'm really sorry to disturb you, but I'd like to remind you of the time limit.
Okay, so this is my proposed work where I try to find the vector difference using the cosine similarity, and this is what my experiment survey where I have performed the experiment on the data set, and we have used different embedding methods like bag-off models, continuous bag-off word, and skipgram in order to preserve the performance using Euclidean distance and the cosine similarity. For each model, for each embedding methods, we can observe that the cosine similarity outperformed over Euclidean distance when we try to find the Hamming distance in order to perform the retrieval during cross cross-model retrieval phase. So my conclusion says that multimodal learning is one of the hot research area going on. Among them, our focus is on the cross-model retrieval, and during the retrieval, our focus is on working of the Hamming distance. Till date, the researchers have worked on the Euclidean distance to find the Hamming distance, followed by the loss. But the work that we have presented uses the cosine similarity to find the inner product between the Hamming distances of the vector. So that's it from my side. These are some references that I have used in order to perform the task. So thank you. Any question?
You have mentioned that cosine similarity, this method is reliable and it is better compared to Euclidean distance, right?
Yes.
So do you think is there any limitation of this method, cosine similarity?
Whenever we try to find the Hamming distance, the cosine similarity works better than the Euclidean distance.
Yes, I got it. But is there any limitation of cosine similarity?
I have not found any limitation because only some part of the work I have represented over here. But when cross-model retrieval whole method I have compared with the existing work which uses Hamming distance, then the cosine similarity in terms of cross-model retrieval always outperform over the Euclidean distance.
Okay, good. Thank you.
Okay, thank you.
Next presentation, please.
Thank you, sir. Thank you, ma'am. We'll be proceeding with our next paper presenter. I'd like to call upon Ria Ashish with the paper titled Media GPT for Image Generation with Enhanced Text. Ma'am, if you're ready, then you may start with your presentation.
Okay, thanks for this opportunity. Am I audible?
Yes, ma'am, you're audible.
Okay, I'll share my screen. Okay. Wait, wait. Wait. I need to remove this. Wait, I'll stop sharing and I'll share again. Can you help me on this one?
Yes, ma'am.
Wait, I think I got it. Oh, okay.
Slideshow. Yeah.
I don't know. I think I need to.
You are currently on a challenging page. No. PPT page.
Cut this. Wait, how do I cut this?
What do you want to cut?
Oh, okay, got it. Okay. Fine. Yeah, cool. Okay. So, can you so this is this okay? Now, okay, no, this is audible. This is being seen, right? Everything is good.
Yes, ma'am, it is.
Okay, fine. Thank you. Thanks for the patience. Okay, so hi, my name is Ria Kavali. I am from PICT, and my research paper is on Media GPT for image generation with enhanced text. That's the name of my research paper, and it is a GenAI based project and it is basically for enhancing text and image synthesis for advertisement industry using we are using multi routing. We're using ChatGPT 5.3 as SLM and stable diffusion and control net. Okay, so our project started 1.5 year, I think 1.5 years ago, as since this is our final year B project, and at that time, these Gen AI models like ChatGPT and all the others, they were new, and they had launched their image processing models, so the image models, which was like text to image models, DALI, and a few others had also launched their models, text to image models. But one of the flaws was that they generated text very well, but they generated image very well, but the text written on it was not good. So to overcome this flaw, we made this project. That's why it's named Media GPT. So it is mainly for poster generations. You can generate posters on different festivals. You can generate it for birthdays. And since it was a B project, we also got sponsorship from ATX Labs, and and I'm really thankful for them for their mentorship in this. Okay, so let's move on to the challenges. Okay, next slide. So these were the challenges which were faced by the existing image generation models. First one was the alignment and image to text integration. There was improper alignment of text with background images, and also leading with poor composition and aesthetics. Then there was image quality and clarity loss, which was like loss of detail and sharpness, which is crucial for high quality advertising visuals and also for generating images in general. And then text coherence and spelling accuracy was also there. So there were a lot of mispronunciations which were noticed. I will also show you some of the images. Okay, these are real-time use cases. So we tried to generate images. This image was generated by DALI. And okay, so if you can see, this is a greeting card. And okay, if you see over here, there are many mispronunciations. The text over here is not seen properly. Also, we don't know what in which language is written. Even the happy is written like this R over here. And the image, if you see, it's good. The image is good. But the text has problems. There's misalignment over here. It's cut. Even like there to the happy birthday is written twice, which there it wasn't relevant. So there are a lot of text related problems and text placement problems, font problems, a lot of problems related to text in short, and very few or even negligible problems with the image. Okay, so our project mainly focuses on combining and creating proper images with good text and the images on it. So both of them should go hand in hand to create good posters. Okay, so even this is another. I tried to create an architectural diagram for ChatGPT and for Media GPT, and it did mess up with the text again. If you see, even the text font is fading. There is even there's mispronunciations everywhere, like workflow diagram. It's wrong. So there are a lot of there were so this project was started a few years, like 1.5, as I said. Right now these models have advanced a lot. So these mistakes which they are making are not seen a lot right now, but they're still relevant, but not a lot. But then since we came up with this idea, and we wanted to go forward with it, we decided this was the best approach. Okay, so now techniques which we use to overcome these flaws. Then we used two models, ChatGPT and Phi3. ChatGPT API key, we used its API key, so we use an LLM, and Phi3 is an SLM. It's a small language model. It is trained on a smaller database as compared to ChatGPT. And we used both of them for text coherence. Then stable diffusion for image quality. Stable diffusion is known to generate images. It's a text to image model. And control net for alignment. Then and also, of course, to combine all of this and create a proper pipeline, we had to make multimodal routing. Okay, we have to use that for efficiency. Okay, so that's basically we created a pipeline. Okay. Okay, so this is important workflow. So how does it work? Okay, then first we take user input. User input, basically we can take two types of inputs. One is an image with text and the other is just text. So we ask them for a prompt, and so we ask them the theme. So for suppose we the user says the theme should be Diwali. Then what should be written on the poster? I want to write Happy Diwali. Since it was because this was for ATX Labs as their sponsored project, what they wanted was that the poster should be generated with proper image and text. Along with that, they should also be able to write from ATX Labs, so that whenever they put it on their social media posts, people will understand it's from them and it's personalized. So it's more personalized and customized. So that's how Media GPT also plays an important role in customizing as per your needs. So yeah, and then you can also include what objects you want to put on the poster. For example, if you want to put diyas, you want to put fireworks, or you want to put a Ram idol and a picture of him on the poster. So you can write all of that there. Then this prompt, which is inputted by the user, is then given to LLM and SLM. So you can choose whether you want to use ChatGPT or you want to use Phi3. Using so difference is that if you want to generate a more advanced, or like not advanced, but a more complex poster, you can use ChatGPT. If you want to you make a simple poster, you can use Phi3. And then the main role of these models, so you can choose which one you want. Okay, and then the main role of this is basically to understand what text has to be put on the poster, then to also see to declare the font of the text, to see how much text it is, to declare the font of the text, to also give the positions of the text on the poster so that it's properly seen and visible. So the text, it basically does the text coherence part on the poster. That's why Phi3 and ChatGPT are used. So text is processed. Its location is declared on the poster. Then a blank image is generated with text. So this blank image, we use PLI library. It's basically a canny image. It takes the coordinates of the text from the ChatGPT or Phi3, and it places it on the blank canvas. Okay, so now you know where the text is placed. Now this blank page is given to stable diffusion, and is told to stable diffusion to add the images in the surrounding areas where there is no text, so that the text is visible and even the images are properly placed. So stable diffusion is a text to image model, and it will place all the images properly, whatever images are required on the poster, along with control net. Control net here is used for precision, to make sure that everything is aligning properly, and it also refers to the canny image. to see whether everything is being aligned properly. Then so that's how the final image is made, by also preserving the text and the image. Okay, now I'll show you. Okay, so this is the front end and back end details. We
Excuse me,
perform.
ma'am.
Yes.
I'm really sorry to disturb you, but I'd
Yeah.
like to remind of the time limit.
Okay, yeah, it's almost done. Don't worry. Okay, so we performed this on Google Colab since we got free GPU access. We needed GPU for this. Then we use ChatGPT API key and also integrated Phi3. These were the two Hugging Face models that we used: the ControlNet Canny and Stable Diffusion V15, and we displayed this image on Grado for front end. Okay, this was one of the final images. So on the poster, we said theme of the poster should be Diwali, and we said it should be written as Happy Diwali, and there should be a diya and the idol of Ram on it. And this is what it gave. So we were pretty happy with the results. Okay. Now, what we did was because we had the front end on Grado, it gives a link which we can share with everyone, and everyone can open it. So we shared it with our friends, and everyone went on to try it. So we shared it with many people, and we also tried it on our own. This was to do black box testing. We did almost 175 tests, in which it passed 92% of the times, and 8% in which it failed were like many of them were like gibberish text, gibberish prompts, in which the model did not understand what to actually put. So like random numbers, random alphabets, like that, we also used those things. But overall the results were good. Okay, why we chose these models? Stable diffusion, greater flexibility for fine tuning and control. ChatGPT, we have superior conversational capabilities with proven track record. Then Phi3 for optimized balance, and ControlNet to enhance the precision and control for adapting generated outputs. Okay. Now the industry use cases. Also in here, I would like to say that the stable diffusion was better because it had the Lion data set, which plays a crucial role in training the stable diffusion, and it gives you better quality, high quality images. Even DALI and Midjourney are equally good, but we could integrate it very well in Google Colab, so we use stable diffusion. Okay, so the industry use cases, of course, the advertisement industry, Media GPT has a wide range of practical applications. It can automatically generate promotional posters with relevant text and sharp visuals for advertisements. Then for social media content generation, it's both engaging and platform specific, even for festivals and promotions. And for ad campaigns, we can use it for hyper personalized invitations for greetings, and also to create e-commerce product banners. So it is and also to create to create birthday greeting cards, with your name, your birth date, if you want a cake on it, or if you want anything else on it. So it does add everything whatever you tell it to add. Okay, so conclusion, to wrap up, Media GPT is more than just a content generator. It's a smart system that brings together the strengths of language models and image synthesis to create visually appealing and context relevant content. So, with advanced alignment, customization, and efficiency techniques, we are making media generation more intelligent and effortless. Thank you. Yeah, that's it.
Thank you,
No
ma'am.
questions from my side. Next presentation,
Yeah,
please.
thank you. Thank you, sir. Thank you for your time.
Sure. Thank you, ma'am. We'll be proceeding with the next paper presenter. I'd like to call upon Atharva Kassa with the paper titled National Disaster Response System. So if you're ready, then you may start with your presentation. Sir Atharv. seems he's having some network issue. We'll be proceeding on with the next presentation till then. Prasanna Lakshmi with the paper title Navigating the Future, Emerging Technologies and the Evolution of ICT Policy in
Hello.
India. Yes, sir.
Hello, sorry, my internet was slow.
Okay, sir. Please go ahead if you're ready with your presentation. So can you hear me?
Yes,
Yeah.
is the screen visible?
Yes, sir, it is visible.
Okay, so hello everyone. My name is Atharva Kassa, and our project is Natural Disaster Response System. Uh, Natural disasters such as floods, earthquakes, and tsunamis can cause massive loss of life and property. Early prediction and proper disaster management can save countless lives and reduce damage. This is why we created a web-based system designed to predict and manage natural disasters more effectively. Our system mainly focuses on these three critical natural disasters: earthquakes, floods, and tsunamis. By using machine learning models, our goal is to provide early warnings to the people in the such areas where disasters gonna occur. So this can help communities and local authorities take necessary precautions before a disaster strikes. In addition to prediction, our system also provides essential resources such as emergency contact information, guidance on what to do during different types of disasters, and way to report incidents quickly. So, to make it user friendly, we have developed an initiative web interface. Users can access the system from anywhere to check disaster updates and view data visualization like maps showing high risk areas and find emergency contacts easily. One of our key objectives was to ensure that the system is scalable so it can handle multiple users and larger datasets as more data becomes available in the future. So, disaster prediction, user interface, emergency contacts, and disaster management. These were the four main objectives. So, in this, we have mainly worked on backend and machine learning, Python, Flask, Skitlearn, Pandas, Joblips, and front end we used HTML, CSS, and JavaScript with Bootstrap and Replit for responsive and interactive mapping.
I think he's having a network issue.
It seems sir has disconnected, so we'll be proceeding with the next presentation till then. I'd like to call upon our next presenter, Prasanna Lakshmi, with the paper title Navigating the Future, Emerging Technologies and the Evolution of ICT Policy in India. Ma'am, if you're ready, then you may
Ma'am,
start with the presentation.
Thank you so much, ma'am, for
uh,
giving this opportunity.
Yeah.
excuse me, ma'am. Ma'am, should I continue the left portion of Atharva Kassa? I'm his group mate.
So if you can, then sure, please go ahead.
Yes, yes.
Ma'am, Lakshmi, you can go next.
Sure, sure. Thank you, ma'am.
Yeah. Thank you, ma'am.
So, am I audible?
Yes, sir, you're audible.
So after this, can I, ma'am?
Yes, ma'am. You
Okay,
can.
thank you.
Yeah.
Thank you.
Please go ahead,
Wait a
sir.
second. Yes, yes, yes. Mm. So, yes, uh, so in backend, we have used technologies of like Python, Flask, its functionalities, word processing model, inference, web server. In machine learning, we have used Skitlearn, Pandas, which is used for data handling, model training, and analytics. For model persistence, we have used Joblib, which is used for saving and loading trained models and preprocessors. Uh, for interface, For user interface, we have used basic HTML, CSS, and JavaScript, which is used for user interaction, navigation, and UI. For design framework, we have used Bootstrap, which is responsive modern design. So yes, now we have achieved accuracy of 91%, 92 or similar 92% accuracy. For future scope, we may increase our scalability by which we can optimize system architecture to handle uh, increased data. Even we can integrate AI-driven insights and real data time streams. Mm. For community, we can improve community alerts by implementing localized alert systems and community engagement tools. So, in conclusion, I would like to summarize. Um, I would like to summarize by our project demonstrates practical application of technology by addressing critical challenges like empowering preparedness, like providing tools for proactive response, saving lives by reducing risk through early warnings, technological leadership showcasing innovation in public safety. So yes, thank you.
Next presentation, please.
Thank you, sir. Ma'am Prasanna, you may go ahead.
Thank you, ma'am.
Yeah.
Ma'am, is it audible, ma'am?
Yes, ma'am, it is visible.
Yes, ma'am. Ma'am, my name is Prasanna Lakshmi. My ID is 1005, and my topic is on emerging technologies and ICT policy. One second, ma'am. There is a technical problem. Yeah. So ICT policy, as everyone knows, it is like in India, it's becoming a evaluation in every aspects. So digital formation and transformation involved through the emerging technologies, which is including blockchain technology, AI, big data technology, things of internet, 3D printing, robotics, cloud computing, and virtual and augmentative realities. So research that where we have to explore the emerging technologies and what is the driven management system to execute the emerging technologies and ICT policies to make the innovation system, and especially policy challenges what across world is facing now, and future policy directions by adopting the technologies and ICTs. Especially if we focus on the support sustainable development goals. So in the area of sustainable, as our international conference, which is related today, is the sustainable development goals. So which is tremendous subject that today we are holding this event. So what I have seen the challenges and questionnaires. Before that, let me tell about myself, ma'am. I'm working as a Chief Innovative Officer for Labor Department for Government of Telangana from India. Uh, then we gone through this so many policies like national digital communication. So there are a lot of gaps in the communications about the data protection. And if we look at the National Policy Information Technology, which is released in 2012, see, this is where lacking about the funds and digital infrastructure mechanism in rural areas. Then personal data protection, still it is the total crime stations of a hub and cyber security is hammering their head about the data protection. So this bill released, but there are a lot of updated what you call that issues and files cased at crime stations it is the evidences for this bill. So the bill is implemented, but still the crime rate is above in the cyber area. So the draft bill that I personally gone through, there are a lot of incorporation and amendments are required as per the crime ratio drastically increased the recent decade from 2009. In fact, if you look at the statistics, and in the national strategy for AI is a boom. Everyone knows we no need to touch upon AI because without AI we are not at all leading a day. The another important policy is about emerging technologies, the blockchain policy. The blockchain framework is such a beautiful framework where the total numbers like banking system, financial industry, and especially cryptocurrency industry, the wherever the especially utilities see. Ma'am, if we especially look at the blockchain technology, where it is implementing, it is in the energy department. So total the power consumptions and everything that is related with the implementation of blockchain, where we control the electricity power and we can give the electricity free of electricity to the agriculture farmers. So there are a lot of policies that I personally undergone with the framework and the related policies. That key challenges, what I've seen about this is, I'm sorry, is about the how to promote and how the area where we can implement the policies and all. The first is sustainable growth, and the second one is the economical growth, and especially in the rural areas, e-governance. So my subject is purely written since I have a 1.5 decade experience in the e-governance by adopting the ICT technologies and emerging technologies, how we can improve the public policies, how we can innovate the things, how we can make the data infrastructure and IT infrastructure, and how we can make data infrastructure in rural areas, and all we can make it with the framework of ICT policy. So recommendations that I can give on my subject is about the country's leverage. Like recently, I've been through. I've been to Cape Town, South Africa. South Africa's policy is such a way they have drafted about the AI and machine learning. Officially, I'm an AI policy maker from Cape Town, South Africa. I can produce my digital certificate. So the strategy that they did the framework such a beautiful to make the complete national digital strategy that they made it, and enhancing of they have added the innovative and entrepreneurship concepts and promoting exclusive entrepreneur concepts and the developing of individual skills. So the policy framework made such a way which is encountering the unemployment, and the world is knows about the South Africa. It's a crime ratio is high, but when we look at their draft policies and all, it is a checkpoint for the crime ratio also. So I personally went through. Then my recommendations for the policy is especially in the development of national digital strategy, investment in digital infrastructure, foster innovation and entrepreneurship, enhance digital literacy, ensuring cyber, nevertheless promoting, including all the technologies that what we have availability. Ma'am, I proposed a beautiful IoT, the things of internet, which is related to the sensors system. I personally promote, as Telangana is famous for turmeric and chili. So we are standing in third position in delivering of turmeric across country, and also other countries like Japan, US, and UK. They are exporting turmeric and chilies from Telangana. The cultivating part, if we implement IoT technologies, IoT technology in agro, so we can make the multi-cultivating system. So farmers profile input. So I suggested kiosk centers, and government is accepted, and it is in the framework for adopting of IoT technology for agro sector to make the to make the disastering pesticides management and personal storage, and especially farm mechanism. So soil management post-harvesting, especially farmers are facing the post-harvesting and the disaster protest management system. see, water scarcity, that we can use the drone technology, no doubt. But coming to the soil management system and post harvesting storage space, that we can purely adopt the IoT technology, that is at bureaucrat level. So I've given a suggestion to the agriculture ministry. Ma'am, this is another second important technology, AI. See, if we look at India's statistics, ma'am, most of the women, they're from rural area. And interesting part, if you look at self-help group concepts, Anganwadi teachers, like 80% of the rural areas, they're struggling for monitoring of pregnant women. See, hope I don't think so, ma'am. You are so young. So one second, one second. Ma'am. So if we look at the anemic, means like if we look at the anemic ratio, that is minimum 40%. North, south, east, west country states in India. So UNO is stating that in every 2 minutes, pregnant woman is dying. This the record is talking about, how painful this is. So this is a simple technology that we are implementing AI in the mechanism of Anganwadi monitoring centers in the rural areas in every centers. In Telangana, we have 44 centers. So I given the, see, for example, if you look at the 5th month, the testing part is a TIFA scan. TIFA scan shows the baby growth, and it is a crucial scanning area where baby minor issues also reflecting in the report. But in the government sector, especially in the medical department, monitoring by the Anganwadi centers, they're not doing it. This is a simple application where we place complete database of the pregnant monitoring database structure on the AI mechanism. It gives you complete record of women and genetic issues, heart hole issues, turn birth child, anemic issues of pregnant women. It gives you complete data structure, and I am showing the process flow and the technical architecture of the implementing of AI in rural area for monitoring of pregnant women. Ma'am, I can challenge, this is one of the beautiful model that I'm personally, because I've covered 250 Grama Panchayat locations personally. I've seen their pain by understanding there. I'm taking this policy to implement,
Excuse me, ma'am.
especially. Yes,
I'm
ma'am.
really sorry to disturb you, but I'd like to remind you of the time limit.
Okay, ma'am. Next
Yeah.
drone, and I'll just wind up in just 2 minutes. Please bear me, ma'am. Thank you so much. And drones implementations in these all the drafting that we are working on the individual emerging technologies policies. And the third eye, that where we can work out on the mining area. Ma'am, our research steps that I'm doing it by the literature review, and I'm in the process of data collection and theory. I'm doing the draft work of framework, and I produce all my drafts to you, ma'am, including my recommendations. And I'll just thank you for this opportunity, ma'am. I'll conclude this by leveraging ICT policy and IET. Countries can promote globalization, liberalization, and socialization, driving economic growth, especially economic development global network. These are my captured. I worked for other states, ma'am. So implementation of blockchain in rural area by the Honorable Chief Minister for Uttar Pradesh, Mr. Sri Yoginath sir, and Karnataka Minister Sri Gundu Ji sir, Dinesh sir, and Karnataka Ministry Honorable Santosh Lat sir for Karnataka state, and also by the American Association Telugu, and by the bureaucrats that so many appreciated me for my framework and all, ma'am. Thank you so very much for giving this great opportunity, and I'll do my best for doing a framework in emerging technologies and ICT policies, ma'am. Thank you so very much for this great opportunity. Thank you so very much for Springer team, ma'am.
I have one question for you.
Yes, sir.
You have done very good analysis for ICT policies in
Yes, sir.
different categories. Okay. So my question is
Ha, sir.
related to only data privacy.
Ha, ha.
Related to data privacy, you have mentioned that there were policy regarding personal data protection 2019 and blockchain framework 2020. These two policies are very much related to data security, right? So
Yes, sir.
government
Yes,
has
sir.
established such policies very well, and they have defined the regulations.
Yes, sir.
But still we have so many cyber frauds and cyber crime. Okay, so
Yes, sir.
can you identify the gap why such kind of incidents were there? Though we have such kind of policies.
Awareness, sir. Sir, only the high level people know the bill. So there is no promotion on the. See, sir, educating on the policies is very important. That the responsibility should be by the
Perfectly right.
department.
Yes, it
So
should
there
be
is no,
aware.
see,
Yes,
law is one of our important area. No one knows about law. So pathetic, sir. So
right,
draft is,
right.
but if you look at their big people, like sir, IAS, IPS officers, they lost their. I'm getting a message from a reputed bureaucrat asking for money 5,000. I was literally shocked.
Yes,
I texted, sir, what is this? You are asking 5,000 to me. What is this? Then it's like it's like fake Facebook. See, data protection bill is available, but yes, what are the there? Where is the state is getting the information on the data protection? Where
right.
is the
Means we have to
analysis is
spread the
doing on
awareness among
the?
the people.
Yes, sir. Where is they doing the promotion and there is no information? They made it a team, sir, like committee. They should make a data protection committee. Day by day, the cyber crimes are increasing a lot. So they should frame a committee for the data protection cell in the and they have to make a promotion to everyone.
Yes,
And
it
they
is
should,
required. And
yes, sir.
data security should be a great threat
Hi,
nowadays.
sir. Sir, the
Okay,
second
good.
point, as you raised, sir, online games. So all are giving information, and Aadhaar is linked to personal number, and personal number is asking by the phone for installing the game apps, and they're losing the money. So can't they
Yes, they are losing.
mention that the data protection bill? The why they're not adding this social activities like social apps, social security apps, sir? They're not doing
Very
it,
good,
sir.
very
So
good.
there's a simple trap they're doing it. They mentioned the naam ke vaste, it's then namesake. They said there is a bill. Execution of bill is important. Awareness of bill is important, and study is important. And regular issues, noticing the issues are important. Bigger people also they're
Yes.
losing data and money, sir. Yes, sir.
Okay.
Please, sir.
Wish you all the best for your work. Thank
Thank
you.
you so much, sir. Thank you. Thank you, sir.
Next presentation, please.
Thank you, sir. Thank you, ma'am. We'll be proceeding with the next paper presenter. I'd like to
Okay.
call upon Agastya Yadav with the paper titled Optimizing LLMs Using Quantization for Mobile Execution. So if you're ready, then you may start with the presentation.
Hello, am I
Yes, sir.
audible?
Yes, sir, you're audible.
Yeah, give me a moment, I'll share my screen. Hello,
Yes, sir.
is it visible?
Yes, sir, it is visible.
Yeah. Thanks a lot, Ishita. Good morning, distinguished attendees. This presentation covers the research project Optimizing LLM Using Quantization for Mobile Execution. Um, the outline of today's presentation would be problem statement, defining the research objectives, describing the detailed implementation and results, and finally discussing the conclusion and future direction suggested by this work. Large language models or LLMs have redefined the landscape of natural language processing, powering chatbots, translation tools, summarization engines, and more. The Llama 3.2 model with 3 billion parameters was chosen with its excellent trade-off between efficiency and performance. Enabling on-device execution is critical for privacy, low latency, and true offline functionality. However, this goal faces severe challenges due to the limited memory and compute capability of mobile hardware. Quantization, and in particular post-training quantization, that is PTQ, offers a path to meaningfully reduce model size and operational requirements, thus bridging the gap between powerful LLMs and constraints of edge devices. Problem statement is that deploying full-scale LLMs on mobile devices is hampered by four major challenges. First, memory footprint. Original LLMs in 16-bit floating point representation requires 6 gigabytes or more of memories, memory while running, while mobile devices have constrained storage and memory capacity. Second, computational demands. High RAM and CPU or GPU requirements frequently results in performance bottlenecks, making current LLMs impractical for mobile usage. Third, deployment constraints. Running large models locally accelerate battery drain and trigger thermal throttling, threatening device usability. Fourth, privacy and latency. Reliance on cloud-based solutions inherently risks user data exposure and slow responses due to network overhead. The key objective is therefore to adapt LLMs for efficient on-device inference while preserving as much as performance as possible. Research objectives. The research objectives are compression, that apply 4-bit post-training quantization to reduce model size substantially. Compatibility, that is to convert the quantized model to GGUF format, employing Llama CPP tools for resource-efficient inference. Deployment, that is successfully executing compressed model on an Android device, specifically the OnePlus Nord CE, my own phone, using Termux and Olama. Performance, rigorously evaluate the quantized model's accuracy with MMLU, that is the standard benchmark used for analyzing the large language models, and compare output quality with the original. Reproducibility, that is to document the entire pipeline from collab code to device deployment, ensuring the process is repeatable and accessible for future research. Proposed system introduction. In this system, the Llama 3.2 model is converted to 4-bit quantized version using bits and bytes framework, and specifically the NF4 variant for enhancing numerical fidelity in low bit widths. The NF4 is normalized 4-bit quantization. The quantized model is then converted to GGUF format using Llama CPP tooling, which is especially effective for inference on a constrained hardware. Mobile execution is demonstrated using Termux, a Linux-like environment, and paired with Olama for seamless command line, that is CLI deployment and testing. The system workflow is as follows: tokenizer input, quantization, GGUF conversion to mobile deployment, forming a robust pipeline for LLM edge deployment. This particular flow diagram is the pipeline that I've created for deploying the quantized model to my local phone. So as you can see here, I am sourcing it from the main model, that is 3.23 billion parameter model. I'm taking it from Hugging Face, and then I'm quantizing it using various PTQ techniques, and then packaging it, and then ultimately deploying it to the device. Moving ahead, I've divided this entire research work into a certain list of modules. Those are model acquisition, quantization, GGF conversion, deployment, inference engine, that is launching CLI app for testing and analyzing outputs, and evaluation for using benchmarks like MMLU and system metrics for judging. I would be covering the modules, two modules together for better understanding. So yeah, modules 1 and 2, that is model acquisition and quantization. The Llama 3.2 3 billion model was selected due to its optimal trade-off between parameter count and hardware efficiency. Quantization was performed using bits and bytes, implementing 4-bit NF quantization with Hugging Face transformers, accelerate, and bits and bytes library. The chief aim was to compress the model while retaining high inference accuracy. After quantization, the model's disk size was reduced from approximately 6 GB to 2.1 GB, representing nearly a 65% reduction without notable inference loss. Now, module 3 and 4, that is GGUF conversion and packaging. Upon quantization, the model was converted to GGUF format. The GGUF specification, central in Llama CPP ecosystem, enables highly efficient inference on low resource devices. The Q4KM quantization variant was specifically used to further reduce the model size and improve inference speed. The final artifact, including the quantized GGUF model and the tokenizer, was packaged into a zip archive for easy transfer from my laptop to the phone. Uh, Module 5 and 6, that is deployment and integration. The deployment environment consisted of an Android 13 device, that is my own phone, OnePlus Nord CE 5G with 12 GB of RAM. Although almost 1 by 6 RAM was used while running, that is 2 GB of RAM. Termux was used to provide a Linux compatible interface and file system. Olama functioned as the inference and model management tool. Custom scripts handled unpacking, correct file referencing, and library compatibility under Termux. This ensured that the model could be launched from a terminal and evaluated in real time with user provide prompts. Evaluations and algorithms. Model evaluation was focused on both quantitative and qualitative metrics. Quantitatively, the MMLU benchmark was used to assess the performance over a variety of NLP and reasoning tasks. The original model achieved 64.2%, while the quantized model retained 61.8%, indicating only minor performance degradation. On-device inference required approximately 2.3 GB of RAM, and average latency was measured at roughly 2.5 seconds for 20 token completion. These metrics were corroborated with multiple prompt types during real-world testing, supported by the MMLU benchmark. Implementations and results. In summary, original model size was 6 GB, which I downloaded. Quantized model in transformer format was 2.1 GB, that was executable in my laptop. And the final GGUF model was down to 1.88 GB, that was running in my low-end device, that is my phone, without any internet. This represents a 68% reduction in storage requirements, which enabled actual mobile device execution. Empirical results confirm that the model maintains comparable fluency and coherence to the original, as validated through question answering and summarization tests. That is the BLEU scores and the perplexity tests. Now, these are the these are the tables that I've created to show the data that has been given out by my quantized model. As you can see, the original Llama model was of the size 6 GB. The 4-bit quantized model using NF4 quantization was 2.1, and the final model was 1.88. The reduction percentages are given as below. Now, this particular table, the second table, MMLU score, is comparing all the relative models which are smaller, which are deployable locally on laptops, and the various parameters, like almost all of them are below 3 billion parameters, so except Mistral. So you can see and you can compare, you can understand that our model, although it is not exactly on the top of the MMLU score, but it competes with the high-end models as well, which are deployable on local systems. This is the graph based on the table, as I've shown in here. This is the graph. As you can see, almost 69% or 68.77% reduction has happened from the original model size. The model size comparison. So as you can see, my model is the smallest in terms of size, in terms of GB. With respect to the other models. The biggest model, ironically, is the model I quantized from, that is the original Llama 3.2 3 billion variant. Conclusion and future work. So, in conclusion, this research demonstrates the practical feasibility of running compressed large language models directly on modern Android devices. 4-bit post-training quantization delivers effective model compression, balancing performance and resource efficiency. For future work, several avenues are proposed. Exploration of hybrid quantization schemes such as GPTQ, AWQ, and SmoothQuant. All of these are quantization techniques, such as what I used is NF4, that is normalized quantization. GPTQ, AWQ, and SmoothQuant are also certain quantization techniques. The next is migration of workflow to native Android interfaces, moving beyond Termux. Now, I have created a Linux-like environment in my phone, but I have not natively operated it. This can be further explored, and it could help the battery efficiency of the model. Testing the methodology on various devices with different hardware profile. Now my device, it is running on my device, which is a 28,000 mid quality, mid flagship phone. So yes, we can generalize it further in the future, integrating privacy enhancements such as local model encryption and sandboxing. These are few references for my PPT. Thanks a lot.
Next one, please.
Thank you, sir. We'll be proceeding with the next paper presentation. I'd like to call upon Sean Menes with the paper title Unified NL Interface for Automating System Commands and Advanced DevOps Tasks. So if you're ready, then you may start ahead.
Am I audible?
Yes, sir, you're audible.
And is it visible?
1 second, sir. Yes, sir.
Okay, then.
Please go ahead.
Okay, so good afternoon, everyone. My name is Sean Menezes, and the topic that I'll be presenting is Unified NL Interface for Automating System Commands and Advanced DevOps Tasks. So the problem statement basically, in today's fast-paced world, to do trivial tasks such as just taking screenshots, managing your file systems, your virtual environments, or repositories is very time consuming and it's very trivial. So to streamline this workflow, there is a need for an automation tool that is proposed by us, which handles the code generation as well as these tasks. This tool enhances the efficiency and addresses these challenges. The scope of this project. Firstly, task automation. So we develop a system that allows to automate the tasks such as screenshots, file conversions, reboots, and even repository management. The next is virtual environment creation. Whenever a developer starts a project, he in Python he needs a virtual environment to manage all his requirements and dependencies. This can be done by our system by just talking with it in natural language. Code generation. Code generation through the use of LLMs can be done by understanding the intent of the user and also then storage of these code files in the local file system as well as running them. To increase the accessibility, we have also increased the amount of languages that can be taken as input. Currently, we can take English, Hindi, and a bit of Marathi also. Voice integration, all these tasks mentioned before can be also done through voice. Coming to the system architecture, the first thing that the user sees is the interface, which is a terminal interface using rich Python to beautify it. Once they enter their text or the voice command, the interpreter code takes over, which is basically an engine that tries to understand the intent. Also, it handles a message handling and it passes the command, which is the natural language input, into code. The execution layer, this is what separates us from just a normal GPT model, as we generate the code and also execute this in the shell using Python and Bash. Data logging and storage. After the command is successful and it is stored to keep track of the chat sessions for future use. Our implementation, as already said, we can use it to run code and create virtual environments, saving uh, the code into file, opening folders or other applications. This is an example of a use case which is like opening your code editor, VS Code. If you write in English, open a new window in VS Code, the first thing is it tries to understand the intent and then generates Python code for the same process. Then it asks, would you like to run this code? If the input is yes, then it runs this code and the code is executed and the new window is created. Similar to that, even if we give a command of opening a browser like Firefox. It understands the intent, generates the code, and then also executes it. I was mentioning creating a virtual environment. So virtual environments require this command right here, this bash command. So if a person who's just a beginner, he might not know this command. So you would just write in, can you create a virtual environment for me? Our system will understand this, generate this code, and also execute it, creating the new virtual environment for the user. This is basically a flow of how when you put an input of 10 of quicksort. So quicksort is an algorithm that sorts an array as given such. The input is taken in natural language. Once that input is been taken in, the next step is lexical analysis, in which basically the tokenization and syntax tree of the sentence is generated. This is then passed on to the intent to code mapping. Here we make use of LLMs, which is Llama 3.17b, which generates the code from the intent, and also uh, the next step is execution and error handling, which executes the generated code, and if there's any error, the error message or the log is again passed back to the uh, system as an input. So if there's an error, you wouldn't be stuck. The system would try to solve it by the same process as before, by less the analysis, intent to code, and then execution. So that reduces the task of trying to solve the error. This are every phase and what the action that takes place. The first is the natural language input, which is basically just a raw text input. The next is a command parsing stage where the tokenization and the syntax trees are made, which the purpose of this is to break down the sentence and understand the various parts of the sentence. The intent detection or the intent mapping is to understand the goal from the sentence. Here, the natural language understanding takes place. Command mapping is getting the intent and then mapping it to Python code with the use of LLMs. Execution is using the Python runtime and the dependencies to run the code. And error handling, as I mentioned before, is if there's any error or log, it can run the process again to solve the issue. Results. So, firstly, creation and running of code. This is an example of printing this. You give an input of print the first 10 Fibonacci numbers. It creates the code and it executes it. So currently, the disadvantage is that we are only focused on Python, and the user input cannot be given in this. When it comes to opening of file and applications, simple tasks that I showed before as opening your text editor or your browser can be done. But if you want to like open a specific uh, tab in your browser, that currently is not possible. The advanced so mathematical calculations can also be taken place with the use of Python again. But the disadvantage is that the complex calculations are still not possible. File storage. File storage can happen when by usage of bash commands such as mkdir and cat. The For better accessibility, we have made a user interface and which also takes in voice input. The voice input sometimes it depends on the quality of the voice. Like if there's background noises, it might sometimes leads to failure. This are graphs that show like the positive and positive success and unsuccessful test cases. When it comes to general test cases, it's 64% successful. General includes everything from code generation to file storage and all bash commands, applications, everything. But when you see only Python test cases like code generation and running of Python, it is 80% successful. To conclude, this project, it enhances the productivity. Obviously, by reducing trivial tasks, we can increase the productivity of the developer. Accessibility is accessibility also is included by having multiple language inputs and a user interface. Reduced human error, since the sometimes human error occurs, the accuracy in our system is higher by using code generation and running. The development cycles are much faster, and the workflow is much more efficient. And also, since you don't need to open multiple things, everything is being focused on in one operation, the resource optimization also takes place. Here are few of the references that we used for the project. And that's all. Thank you for your time. Open to discussion.
No questions from my side.
Okay, thank you, sir.
Thank you, sir. I'd once again like to ask for Vedant Chandore. If you're here, then you may start with your presentation. Sir Vedant? It seems we do not have him, so that brings us to the closing of the session. I sincerely thank our authors for the excellent presentations and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you for your support during this 10th version and all the previous 9 versions of the conference. We will be happy to have you in the 11th version in 2026. All the presenters will be getting their digital certificates through email within 2 working days. Furthermore, all the papers have been already forwarded to the Springer. The publication will be live within 7 to 8 months. Kindly cooperate with the team of ICT4SD 2025. I'd also like to thank our session chair, Professor Vinod Kumar, for chairing the session. A token to the chair on behalf of Team ICT4SD and Global Knowledge Research Foundation. Thank you for your valuable presence, sir.
Thank you. Thank you so much.
Just before we end the session, I'd like to request everyone to turn on their cameras for a quick snapshot of the virtual conference. Thank you, everyone. Thank you. Stay safe and take care.